Dear friends, it is the fourth lecture, and in third lecture we have discussed about the population inversion. So now we will exactly see the meaning of population inversion. Population inversion, that N2 must be higher than N1. Number of atoms in excited state must be higher than the number of atoms in ground state. Just now we have a formula here, that is N2 upon N1 is e to the power minus h nu upon kBt. What is h nu? That is the energy difference between ground state and excited state. That is the energy difference h nu. So if we take natural log both sides, then ln n2 upon n1 is equal to minus h nu upon kBt. Normally, to have atoms in excited state, we use temperature and we increase the temperature. So we can have a temperature where this population inversion can be achieved, and that we can write formula minus h nu upon ln n2 upon n1 kBt, or in other way we can write minus h nu upon only kb, and natural log L1 n2 upon n1. This is the formula. So we can have temperature from here, so that we can get the population inversion, that number of atoms in excited state is higher than the number of atoms in ground state. So for that we have three situations. These are the three situations. The first situation, that is at t equal to 0k. Second situation, t is greater than 0k, or we can say at room temperature 300 Kelvin, and it is t is infinite k. It is the highest temperature and it is the lowest temperature. So from this we will have the idea that where we can get the population inversion. This is the first state, it is second state, that is ground state, and it is excited state. Number of atoms are n1, and here number of atoms are n2. Generally these are the atoms in ground state. So generally what we have, that number of atoms in ground state is there at t equal to 0k, and n2 is completely empty. And from this formula we can have that t equal to 0 means we want this 0 means this term must be infinity, and this term will be infinity when this should be infinite, and this should be infinite as we know that log 1 value is log 1 0, 100 1, 1000 that is 2. This way the value is increases. That what we can have, that this term, if we want to get this infinite, this term must be infinite. This term infinite means this value must be infinite, and infinite means always this n2 must be 0 and n1 must be higher. 0 upon 1 is infinite, and log infinite value is infinite. So this term will be infinite, and in that case n2 will be 0, means no atom will be in excited state. At 300k we know that atoms in ground state and some atoms are in excited state, that here n2 is 0 and here n2 is much less than n1. Now we come at infinite, t equal to infinite. This term t must be infinite. This t must be infinite. T must be infinite when this term is 0, and this term is 0 means log 1 will be 0. Log 1 will be 0, and log 1 will means n2 is equals to n1. Means if there are number of atoms in ground state and excited state, then n2 is equals to only n1. Again, t equal to infinite k. This term we need infinite. T equal to infinite. This infinite means this must be 0 and this must be 0. Log 1 n2 upon n1, log 1 is 0, so it will be 0, means n2 is equals to n1. That at infinite k, even infinite k, we have only n2 is equals to n1. No population inversion is there. Means the concept of temperature that we have is not fulfilled here to get the population inversion. So what we have to do, that again we have to have the atoms in excited state further interacts with incident energy and they will reach in metastable state, and from the emissions from this metastable state will be known as stimulated emission, and we will get laser. So to get laser, always the atoms in excited state will further interact with incident energy, they will reach in metastable state and they will come down to ground state. Initially, first, this was used in MESR, that is microwave amplification by stimulated emission of radiation. Microwave means only 10 to the power minus 6 meter wavelength. In light, we have 10 to the power minus 7 meter. This is used with ammonia atom, that ammonia atoms interacts with incident energy, they will reach in excited state, and further interacts with incident energy, they reach in metastable state, and from the emissions from metastable state are known as the stimulated emissions from metastable state are known as stimulated emission. And initially MESR was produced, that is microwave amplification by stimulated emission of radiation. And then after that, the 10 to the power minus 7 meter wavelength, that is light, was produced with the same technique, that atoms will go in metastable state by further interacting with incident energy, and we will get the stimulated emission, and this stimulated emission will be producing laser. So this is about the